this video we're going to take a look at the different points inside of a template or a component, how they can be controlled, what the hierarchy of that control is, what all the different settings for those points are. When you create a template or a component, points make up every edge or every location inside of that component, and those items can typically be controlled either with point controls or parametric constraints, but they're also given an initial distance or slope, something of that nature. So when you look at points, first off, I'm just going to go into my MicroStation file here, and I'm going to go ahead and open up the template library. So we're going to be under the Open Roads Modeling, Corridors, and we're going to go to the template icon there. We're just going to left click on the Create Template. That allows you to pull up the ITL to work with. When you first do this, it pulls up the mo.itl. If you have one saved in your project, you'll open that up with a file open. And then it's going to go out into ProjectWise, and it's going to take you to a specific spot in ProjectWise. So on mine here, we're working in the Miller County folder, job number. We're going to be under the roadway area, and this is data 4, and I've got a class mo.itl in there. So that's the one I'm going to go ahead and grab for this. Okay, as you can see out here, we've got our template library set up, and to look at the points, I'm going to go in here underneath the components, and let's just take a look at pavement. So we've got pavement new here, pavement only. I'm going to take a look at the asphalt, and just that first one in there, asphalt pavement. Single click, it brings it up in this window, in the preview window. If I double click it, it will open it on the right. That's what I want to do, double click it there to open it over there. As I was saying, everything is made up of points that are connected to one another. And there's 3 different colors of points that you can have. There's the green point, which we have here. Typically, that's going to be at your origin, because you don't want it based off of anything else. But the origin still could be constrained a little bit. But typically, those are going to be green, which means it's not constrained at all. So it's going to be wherever it's at, 0, 0. So if you've got a horizontal and a vertical element, this template will draw this point along that horizontal and vertical element. Okay, so that's a green point, has no constraints whatsoever. So let's double click on that point and take a look and see what I'm talking about here. So when you double click on that asphalt surf TCL, you can come down here and look at this information. There's a super elevation flag. If this was to be super elevated, or it could be super elevated or be used with the super elevation tools, it'll be check marked there, and super elevation will look at that. Typically for a center line, that'll be your pivot point for your super elevation, but it has to have that flag on in order for super elevation to be able to use it and see it. The alternate surface area, we've got some tools in the terrain modeling tools that will allow us to create a surface based on any points that are marked with this proposed finished grade. So our top surface would have this proposed finished grade. It'll go out and see that alternate surface, and it can create a surface based on those points that have this turned on. Okay, your constraints down here at the bottom, it says none and none. That is what it's turning this point green. If you had one constraint, it would be yellow. If you had both constraints filled in, then it turns it red. As you can see, most of those are red out there, so they are having 2 constraints. And they will be based on a parent point. So let's say this asphalt surf T EOP, let's say it's about 12 foot away from the center line. So one of your constraints would be a horizontal constraint, 12 foot. If that's all you had, the point would be yellow. Then you'd have a slope, maybe 2%, so you could change this constraint here to a slope, and give it a 2% or negative 2%, and that will turn the point red because now it is constrained horizontal and is constrained vertical or slope. Okay, so the horizontal feature constraint at the bottom, if that's turned on, it will go out and search for a linear element that we have in our 2D window. Okay, our 2D window, because it's only going to look for horizontal feature constraints. So if you're looking for, say, an EOP or edge of shoulder or a ditch line or anything like that, you would fill out that dialog there with the correct feature definition, and then you would add that line that you're looking for into your corridor, and this point would override the information in here horizontally and go seek that line. So if you had this at 12 foot out here and you decided, well, it's 12 foot unless I see an edge of pavement line that I have drawn in my file, then go out and hit that line instead of this 12 foot. Okay, we're going to talk about that a little bit more as well. So I'm going to close out of this first one. You saw that was a green point. If you take a look at the red point, the asphalt surf TEOP, you'll see that it is similarly set up, super elevation flag, so it will have super elevation take effect on this point if you want it to. And it's also got a feature definition set up to it here, so it knows how to draw it in the plan view, and it knows how to draw it in your cross sections. Okay. There's a member of area. This point is a member of the asphalt surface pavement, so up here at the top. Now if there was another piece on this, if there was a shoulder or an end condition, it might be a member of more than one element, okay, more than one component, and it would list it here. So that point, if they were merged, could be part of this pavement and part of a shoulder or part of an end condition, and it'll be listed here. Okay, so here it is. Here's why it's a red point again. We've got a slope and a horizontal constraint. Now there's all kinds of different constraints in here, and we've got those in the actual manual here, types of constraints that we have. And there's a little list right up here also about point constraints. I've talked about this one. Partially constrained is yellow, fully constrained is red, and then your unconstrained is green. So that's spelled out here in the manual. And then we've got all kinds of different constraints that we can put on these points, a horizontal and a vertical, which controls both horizontal and vertical. You can put a slope to it. Horizontal maximum minimums, vertical maximum minimums, we don't use these that often. We're not really going to go over those in Road 1. But on the horizontal maximum, the child point has 2 parent points and remains at a specified horizontal distance from the parent point. That is the furthest to the right. So it has the maximum horizontal or X value. So you can read down through those. We don't really do a lot of those. Vertical offset or vector offset, we do that one quite a bit. What that does is if you've got a, let's say, I'll go back into the drawing here. Vector offset is if you had another point out here to the right of this one, and you wanted to have that maintain the slope of asphalt surf TCL to asphalt surf TEOP. So whatever that slope is, you've got another point out here that wants to basically just come right off of that slope and be the same as that slope, or it could be the same and then down 2% or up 2% or whatever you want that to be, but it bases its slope off of whatever the slope is between the 2 points that you give it. So how that works is you've got a slope here right now at negative 2%, okay, and it comes from the asphalt surf TCL, so we're down 2% at this location. So if you wanted to see what a vector offset would look like, you could go there. Now the vector offset needs 2 parent points, so you got to tell it that it goes from between this point and another point to base its slope off of. And then the value, if you leave it at 0, it's going to go exactly on whatever that slope is. Okay, but if you give it a value of say -1 or +2 or something like that, then it would be that slope, then down 1% or up 2% or whatever information you put in the value. Okay, we'll be doing some of that in our exercises that we have coming up. you notice that there was a label in here. This label is used for parametric constraints. So let's say that we have from asphalt surf TCL to the asphalt surf TEOP, we've got negative 2%. But if we're going to place this in our corridor, and it's going to meet up against another corridor or maybe an existing uh, surface out there, and we know what the slope is. Let's say at the where this corridor ends, it's only at 1% existing. So what you would do is use these labels as a parametric constraint and say from one station to another, let's say from station 100 to 110, we're going to go out here and go from negative 2% down to a negative 1%. So if you wanted to do that, you'd have to have this label right here, and that allows it to control this with a parametric constraint. And we're going to go over parametric constraints in another chapter, so it'll probably make more sense there, but that's what this label area is for. You cannot create a parametric constraint for any of these points out here unless there is a label. And you can type whatever label you want in here, so it doesn't have to be the default that you see here. You can type whatever it is that you want in this location, and it will show up in the dialog for parametric constraints. Okay, and then this particular point does have a horizontal feature constraint, and it's set, typically you set that to an edge of pavement. So you would come down into your linear, your design, then you're looking at your roadway items, and then we would scroll down and look at maybe an edge of pavement new line. And then if you went in your drawing and you drew an edge of pavement new line in your 2D view, you could have it search for it and draw out to it. Okay, the range is pretty much how far out from this point it's going to look. So it's going to look out 50 feet. For that, you also have to add that line to the corridor, which we're going to talk about in the corridor chapter. Okay, but that is your points for this one. That's how they're all set up and created. The horizontal one here is basically 12 foot away from that parent point here. That's this point located 12 foot away from there. It also has a parametric constraint label placed down here so we can control that width with a parametric constraint. So between one station and another station, we can change it from 12 foot and have it taper down to 10 foot or out to 14 foot. Again, we'll be doing that in some of the exercises and chapters later on. Okay. The next thing that I want to take a look at is in your end conditions. So let's go over here to the left side and let's close down the components and take a look at end conditions. I just want to look at a ditch here real quick. So we're going to double click on ditches and double click on ditch. Okay, so this is an end condition, and it's basically it's a different type of component that will go out and seek either existing ground or another surface, or it can actually seek different elements that are out there and try to basically close a shape for your end conditions. And that way in earthwork it knows how to cut things out or fill them in. Okay. It doesn't have to be existing ground, but for road 1 most of the things that we're going to do is going to be on existing ground. So that's what we'll go over here. So again, you have a green point. So if you were to drop this on the edge of a shoulder, that would merge with the edge of shoulder point, and so you would have that there. But if I double click on it, you can see that end conditions have a little bit something different in them. First of all, you won't have a super elevation flag. You won't have those trying to super elevate. They're typically still part of the proposed finished grade. And then down here on the left hand side we've got this end condition properties. So that's something different about an end condition point or component than a regular component. Okay, so we're having it check for interception and place a point at interception. There's also a do not construct here at this point. If there's points out here that you could say I don't want to construct it at all, and it won't actually create the line work. But this one's going to check for any interceptions. So if that point right there is already on existing ground, it just won't draw the rest of this ditch in here, and it'll put a point there. Okay. There's no constraints on this one because that is our origin point. So let's take a look at one of the other points that we have. The ditch 4 slope 1B. Let's look at that one. Okay, the ditch 4 slope 1B, I don't want that to go seek any ground or anything. I need it to be out whatever I tell it. It can go, it can be point controlled to go out and seek a line if you've got a special ditch line that's got elevation to it. You can do point controls later, but basically with this one you're going to tell it what kind of slope that you want on here. So maybe a 4 to 1 or 2 to 1 or 3 to 1, whatever you need in there. And then you can control that with a parametric constraint as long as you have the label. And then it's going to draw it out 24 foot. So this particular ditch is going to go out 24 foot unless we tell it differently. But that's by default. But we don't want it to go seek any existing ground or anything like that. We're just going to have it draw out to what we tell it to. Okay. If I look at the, go ahead and close that and look at this last point, the ditch back slope. The ditch back slope is something a little bit different about it. You can see it's a red text where the others are white text. On the red text, we're using a feature name override. And what that's doing is it's giving it a feature definition out there so that it can know, the program can know that that is a cut location. So out there in your plans, it'll draw a cut line for you. And that will help in determining whether you're in cut and fill. So that's what we've done here. Limits of construction, cut. Okay. There's a fill slopes and all that in here, and that'll be an LOC fill whenever you use one of the fill slopes that we have. Okay, down here at the bottom, the end condition properties, we want that now to check for interception, place a point in the interception, and then the end condition is infinite, which just means that this point is going to go at this slope 10 foot, but it's also going to be infinite. So I'm going to draw it up here at 10 foot, but I'm also going to, if it's further, going to go seek that existing ground that's out there however far I need to. Now once it finds it, it'll stop at that location. Okay, so that's kind of what is different about end conditions with the points. So I'm going to close that. The other thing I'll just touch on real quick, this is more of a Road 2 type thing. We're not really going to do much of this in Road 1, but if you left click on this end condition and double click on it, you'll pull up another dialog that deals just with that end condition and not the points themselves. And what I would just look at in here is this end condition properties. Our target type right now is a terrain model, the active terrain model. Okay, if you had other terrain models in here, you could click on them and have this particular end condition go seek that. So instead of doing existing ground, you have another surface out there that you want to hit. Then you can plug it into this information here, and now this end condition will go seek that other surface and not the active terrain model. You can also seek other things, a specific elevation, a linear and horizontal elements, different feature definitions, horizontal and vertical, or both. And like I said, in Road 1, pretty much we're just going to be looking at the terrain model for this. And there's different priorities for this. This is a priority 2. So if I have a fill slope in here, that'll be priority 1. And it would do that one first and then come back in and put the ditch. If you wanted to switch that around, then you would make this a priority 1 and a fill slope that we would place out in here as a priority 2. That's where your conflicts come in, whether you're going to have a priority of 1 or 2 on these end conditions. Do you want to solve for a ditch first, or do you want to solve for a fill slope first? Okay, so I'll go ahead and close that out for now. I think for as far as Road 1 goes with the different points and the end conditions, that's mostly what we'll be going over. So we will be doing exercises in the next videos. If you have any questions, feel free to contact us at CAD Support.